In this section, we're going to talk about the law of sines. This is 9.3 for trig. So what we remember from the last section is that we talked about how to find the area of a triangle that is not a right triangle. Obviously, with right triangles, we can do 1/2 times base times height. In these ones, what we did was we dealt with two sides of the triangle and the angle in between them. And what you can see is these are all the three area formulas that are all equal to each other. Okay, 1/2 times AB. So if we have sides AB, then that means that C would be the angle that's included. If we have B and C, then A would be the angle that's included. And if we have C and A, then B is what is included. But all three of these formulas would give us the exact same thing. So now dealing with the law of sines, that's where the law of sines comes from. Because if we were to divide out 1/2 times A times B times C from every single one of these, this is what we would be left with. We'd be left with the sine of C divided by C is equal to the sine of A divided by A, sine of B divided by B. So basically all of these are like proportions and they will always be equal to each other. Keep in mind the one mistake that is made on this is very, very easy to do, but the one mistake that you may make is remember that the angle C and the side C are always opposite of each other. So when we do the problems, you have to make sure that you're looking opposite of where the angle is. So let's just get right into this example. We have the sine of 60 degrees over. Now again, we have to look opposite. The mistake would be to look right above it and say that it's X, but really the opposite of this angle is 8, so 8 has to go on the bottom. And then the other side will be the sine of 25 degrees divided by X. And then we just solve this using a proportion. So we have X times the sine of 60 equals 8 times the sine of 25. And then to get X by itself, we just divide both sides by the sine of 60. And then we can just put this into a calculator to figure out what X is equal to. So you do 8 sine of 25 divided by the sine of 60, and we actually get X equals 3.904. Simple as that to find a missing side or missing angle of a triangle when we have these corresponding correctly. Okay, so this one I want you to do on your own. This is going to be this could be a little bit challenging. Don't be surprised to get a weird answer. So when you get that, don't think that all of a sudden you're doing something wrong. But what I want you to do is when you get your weird answer, I want you to try and think about maybe why that would be. Okay, so answer to the best of your ability, and then obviously we'll go from there. So when you did this, kind of hoping that when you got to your proportion that one, you realize that you're trying to solve not just for sine of B, but for actually B. So you would have gotten sine of B equals 1.25. That doesn't mean your answer is 1.25. You actually have to do the inverse sine to figure out what your angle is going to be, and you should be getting an error. And it's like, okay, well, what does that mean? Well, in reality, what that means is, first of all, we cannot, a sine will never be equal to something greater than 1 or less than -1. So that's something that we haven't really learned yet, but that's just to throw that out there. But what it really means is that when we try and construct this triangle, it means that the sides won't ever connect. It means the sides are not long enough to connect the three sides. So we would have a triangle that would be like partially done. So it would look maybe something like that. Okay, so that's what an error means. It means that this triangle doesn't really exist. So that was a little twist that I threw in there for you because that is important for you to understand that. But basically the same methods are going to be to find everything. The first method in the first problem was when we were looking for a missing side, really easy to find using proportions. The second method for finding a missing angle is going to be you just have to make sure that you use your inverse at the very end to try and solve for that angle and not thinking that you're done right here. Okay, so really that's the only two methods that we're talking about with the law of sines, and we'll get to more of it in class. So I'll see you then.